All right, so here we are on part 3 of the series, and we're going to walk through the process of importing a drawing and setting up the cut path and saving a drawing and that kind of thing. So you want to click on the File menu here and go to Import, and then pick the file type that you're wanting to import. In this case, we're going to do DXF. So I'm going to pick the very top one, and if you notice, there's a little preview check mark here where you can get a little preview of what you're importing, and it's also giving you the dimensions of what it is that you're porting, so you can see what it's scaled at right here in the preview. So I'm going to click OK to that, and you see it brings in our drawing. Okay, so from here, maybe one of the first things that you want to do is scale or change the size of the drawing. So again, you're going to drag across all of it so it's turned into dashed lines, and then you want to click on Scale right here, and you can scale the whole drawing. Here, this is 23.5 inches wide. If we wanted it, 48 inches wide, we could just change it right there and rescale it. So that's how you rescale. So when you, one of the first things that you want to do is sometimes, depending on the drawing, SIP cut will not recognize what the outside contour of that is, and you have some options that you can do here. But one of the ways that you can tell is, let's go ahead and put a lead on it. So right up here, we're going to click on the lead to bring up the lead dialog box. And, it's coming up saying it's going to give us a 0.25 straight line, 90-degree lead. So we could just say okay to that, or we could change it, make it 0.5, whatever you want to make your leads here. And I'm going to click OK on that. And you can see that it moved it down here. And what you want to try to do on an outside contour with a lead, if you want to have it not have a witness mark as to where that lead is to put this on a 90-degree corner. And if you've had experience with CNC plasma or other CNC, you know that this is a common method to be able to hide your outside lead. So if you want to move your lead from where it is to where you want it to be, you go up here and click on this lead position. And if you come in and click, you'll notice that it'll start to, wherever it thinks it may want to put it, it'll turn it into a box with the crosshairs there. So now it's going to lead in, and it's going to cut in the direction of the arrows. You can see the white arrow there and the green arrow here, and go all the way back and cut and finish up right here, and finish up on an area where you wouldn't be able to tell what that is. So everywhere that you see a white dot, that is representing where it thinks it wants to put the lead now. All right, so you see that we've set the outside lead in there. I know I kind of jumped the gun on this, but the main thing I wanted to show you was that sometimes on the outside contour, it won't recognize that it's outside if it's got some kind of an issue with the drawing or whatever. But if it's set up not to recognize the outside, and look, here, let me just, since I did this real time accidentally, this software, I don't know why it is, but it's really sensitive and easy to kind of pick up a part of the drawing. And I have made mistakes where I've accidentally picked up a bolt hole or something and moved it a slight amount without even really meaning to. And if you don't move it very far, you might not even realize you did it until you cut it. And so just be really careful of that. I'm going to just undo that to get that to go back. So what I wanted to show you was if you create the lead and you notice that it's actually trying to lead on an inside lead on what should be the outside, the way you can correct it very quickly and easily is just highlight that contour like that, and you see the lead in there. And then if you go up here to you get these two toggles, so you just click on outer and it automatically moves it to outer. And if it's going in the wrong direction, which it should be going clockwise on an outside cut, you can just click the reverse here, and that will toggle the reverse. So you can toggle inner and outer and toggle the direction of cut with those two things. But in general, it should recognize it and know, what direction everything should be cut in. But the rest of your drawing, everywhere you see a white dot, represents the pierce point or the lead point, start point of the drawing. And so let's go ahead and set the leads for the inside part. And you could do this one of two ways. You could highlight all of it and then hold down the shift key and select the outside contour. And if you see that, it's in solid green and the inside's all broken up, which is an indication that the that what's highlighted are the only are only the inside cuts. You could do that and then set your lead for that, or you could just highlight all of it and then go up here to lead. And let's just say we want to give this an arced lead in on an inside cut, and we're going to make this 45 degrees on the arc lead in. We're going to make this a little bit shorter. We'll just go to 0.2 on that. So because we have the whole drawing selected, we could say, click the check mark right there so that it will only apply that to inside contours. And if we zoom in, you will see all of our inside contours now have a 0.2 arced lead in. And now that you've got this fully set up, you could go ahead and click your lead position and just kind of scour down and make sure they're in a good spot. And some best practices are, make sure you don't have it in an area that is too close to the next lead in, or too close to or in a corner or something. And I'm just trying to find one that may be a good example. All these look like they're in a pretty good area by default and would cut pretty well. But sometimes they can be in a little bit of a funky place. All right. So after that, another thing that you can set, and we can get into this in a more detailed fashion later, but let's just say we wanted to micro joint the letters so that they don't tip up. And if we wanted to have a micro joint on it, so you would click whatever you wanted to be micro jointed, and then click this micro joint area, and then auto micro joint. And you could tell it how many you want around the entire document, or around the entire contour. But if you just specify one, then it will default to putting the micro joint at the lead in, which I have personally had pretty good luck with. But you can experiment with it and place it in different ways depending on what it is that you're cutting. So right here you see that it's giving us a micro joint lead of 0.079. And if you're cutting thin sheet metal, that's going to be a little bit too big. If you're cutting thicker material, then a good starting point is whatever the thickness of the material is, go with that. So if we were cutting this out of 16 gauge sheet metal, you could make this 0.06. And go even down a little bit further than that. It depends on, how strong of a hold you want on it. If you get down on 16 gauge sheet metal down to 0.03, 16 gauge sheet metal is 1.6 millimeter. If you have a lead in of 0.03, it may or may not hold it. It may be enough nitrogen pressure to actually break the lead in that it leaves. So, somewhere between 0.03 and 0.06, 0.05 might be pretty good, but we're gonna select that and look at our lead in. Why did that not take? Let's try that again. So we're gonna go micro joint, auto micro joint, apply to selected, 0.05. Oh, right here. So you see that we had a void start point selected. So if we click this again and we zoom in, you'll see the micro joint is at the start point. So this thing's going to lead in, make its cut all the way around the letter, and then when it gets back to the lead, to the start point, it's going to stop a little bit soon, and it's going to leave a tiny little gap right there. And the lead in type can also affect how big your micro joint needs to be. So if you see this arc is kind of encroaching in on the space that it leaves, if you change that to a straight lead in, you would actually want to run a smaller micro joint. So that's a real basic orientation on micro joints. If you want to clear the leads and the micro joints, if I just click this one to highlight it, and we'll zoom in where we can see it there, so we can see the micro joint. The way you clear it is to come up here to clear and then say clear micro joint, and you see it got rid of it. You could also clear the lead. So clear the lead right there, and now it's not running any lead, and it's moved the lead point back. Okay. So that is a very basic orientation on on setting your cut path and your leads and lead outs and micro joint concept there. So if you want to save this so that you could not have to rework all that again in the future, you do save as, and you save it as a LXD format, and which is a laser dock 2.0 format. So we're going to save that, and we're going to just delete this out of here, and we'll just go ahead and create a new one, for example. So now we have a blank canvas. Let's say it's a week later and you want to cut another one of those. So now you can go File, Open, and reopen your Harley.dxf, and you can see our lead point that we've already set, and the other leads that we've got is just like it was when we last left it. So you don't have to redo your cam cut path operations in the future. So that's a really basic, setup of the job. And after that, you want to go and set your parameters of what kind of material it is. So we're going to switch to the next video on setting the cut parameters, which is going to be, a lengthy video in and of itself.